So in addition to the constant multiple and sum laws, which was the previous video, we also have the product, quotient, and power into root law, which is basically the same thing. But often when we are using these more complicated ones, product, quotient, and power root laws, we have to use the constant multiple and sum laws. So we have to make sure that we are confident with those before trying the more complex questions, as with any concept. So the first law that we're going to look at is the product law, which states that the limit of f of x times g of x as x approaches c can be broken up into the limit of f of x as x approaches c multiplied by the limit of g of x as x approaches c. This just helps us so we don't have to spend more time foiling the two functions, which can account for more errors, which can just make life a little bit more difficult. So with this, we can try and eliminate a chance for error. So a couple of practice questions and that are super easy. So the first one is limit of 4x plus 1 times the limit of 6x minus 1 as x approaches a half. So let's use a different color. We can break this up into the limit as x approaches a half of 4x plus 1 all multiplied by the limit of 6x minus 1 as x approaches a half. And then using the constant and the sum laws, we can break this up into 4 times the limit of x as x approaches a half plus the limit of 1 multiplied by 6 times the limit of x as x approaches a half minus the limit of 1 as x approaches a half. And once we plug our numbers into this we get 4 times half plus 1 multiplied by 6 times a half minus 1, which gives us 3 times 3 minus 1 equals 2, which gives us 6. Just our final answer. Okay. Our second question is the limit of x times x plus 1 times x plus 2. A little bit more complicated just because there's more things to be multiplied by, but same rule applies. We can just break this up into the limit of x. Oh, this is when x is approaching 2. Sorry. So we can break this up into the limit of x as x approaches 2 times the limit of x plus 1 as x approaches 2 times the limit of x plus 2 as x approaches 2. And then we can this is just the limit of x as x approaches 2 times the limit of x as x approaches 2 plus the limit of 1 as x approaches 2. And then the limit of x as x approaches 2 plus the limit of 2 as x approaches 2. So to make this numbers, the limit, this becomes 2 times 2 plus 1 times 2 plus 2. So 2 times 3 times 4 equals 24. That is our final answer. Moving on to the quotient law. So the quotient law states that if g of x does not equal 0, which means the limit of f of x over g of x can be actually solved. As x approaches c, we can break that up into the limit of f of x as x approaches c divided by the limit of g of x as x approaches c. Same thing, we're just breaking it up so it's easier to deal with. So a first example is the limit of 3t minus 14 over t plus 1 as t approaches 4. So to break this up, we can just say the limit of 3t minus 14 as t approaches 4 all over the limit of t plus 1 as t approaches 4. And then using, once again, the constant multiple law and the sum law, we can break this up into the 3 times the limit of t as t approaches 4 minus the limit of 14 as t approaches 4 over the limit of t as t approaches 4 plus the limit of 1 as t approaches 4. So making this into numbers, this becomes 3 times 4 minus 14 all over 4 plus 1, which gives us 12 minus 14 is negative 2. 4 plus 1 is 5. Our final answer is negative 2 over 5. Another question that involves the quotient law is the limit of x over x cubed plus 4x as x approaches negative 1. So we can then once again break this up into the limit of x as x approaches negative 1 all over the limit of x cubed plus 4x as x approaches negative 1. And then once again, using constant multiple law and the sum law, we can break this up even further into the limit of x as, the limit of x as x approaches negative 1 over the limit of x cubed as x approaches negative 1 all over plus 4 times the limit of x as x approaches negative 1. And then we make this into numbers. So limit of x as x approaches negative 1 is negative 1. Limit of x cubed as x approaches negative 1 is negative 1 plus 4 times the limit of negative x is negative 4. So negative 1 over negative 5 equals 1 over 5. Okay, now we can move on to the power and root laws, which state that the limit of f of x to p over q, assuming that q does not equal 0, because if it equaled 0, it would not be definable. So the limit of f of x all to the power of p of q as x approaches c can be simplified into the limit of f of x as x approaches c all to the power of p over q. So we can try a couple questions. Are we still in blue? We are. Okay, so the limit of 18y squared minus 4 all to the power of 4 as y approaches 1 over 3. So we can simplify this into the limit of 18y squared minus 4 all to the power of 4 as y approaches 1 over 3 as the previous rule has suggested, and then we can break up the inside a little bit more using more limit laws. So this becomes 18 times the limit of y squared as y approaches 1 over 3 minus the limit of 4, and this is all to the power of 4. So 18 times 1 over 3 squared minus the limit of 4, which is just 4, all to the power of 4. So 1 over 3 squared is 1 over 9, 18 over 9 is 2, minus 4 to the power of 4 equals negative 2 to the power of 4, which equals 16. Second question. This one is not too different. It's just involving quotient rule, so getting a little bit harder. But same idea, just break it up into what we know. So this becomes the limit of, so first we're going to do quotient rule because we need to isolate this to make, to simplify it further. So it becomes the limit of 3 root t minus 1 over 5t as t approaches 25 all over the limit of t minus 20 squared as t approaches 25. This becomes, if I could give myself a little bit more space, this becomes the, 3 times the limit of root t as t approaches 25 minus 1 over 5 times the limit of t as t approaches 25 all over. This is where we apply the product rule, the limit of t minus 20 as t approaches 25 all squared. So plugging in numbers, we get 3 times square root of 25 is 5 minus 1 over 5 times the limit of t. So the limit of t is 25. 25 divided by 5 is 5 divided by the limit of 25 minus 20 is 5. The limit of 5 is 5. 5 squared equals 25. So 15 minus 5 over 25 equals 10 over 25, which simplifies down to 2 over 5. So with what we know right now, we can combine a quotient and a product question for a more complex question once again. We can give ourselves a little bit more space. So this would become the limit of t squared plus 1. Oh, this is as t approaches negative 1. T approaches negative 1 all over the limit of t squared plus 2 as t approaches negative 1 times the limit as t approaches negative 1 of t quad plus 1. So this becomes the limit of t squared as t approaches negative 1 plus the limit of 1 as t approaches negative 1 all over the limit t cubed as t approaches negative 1 plus limit of 2 as t approaches negative 1 times the limit of t to the power of 4 times t to plus limit of 1 as t approaches negative 1. Plugging in numbers, we get 1 plus 1 over negative 1 plus 2 times 1 plus 1. So 2 over 1 times 2 equals 1. And finally, we have the root rule, which is basically the same thing as the power, just applying it with roots. So as with power, if the limit of the nth root of f of x as x approaches c, we can simplify that to the nth root of the limit of f of x as x approaches c. So first question, the limit of x plus 2, the limit of root x plus 2 plus 1 over the root x minus 3 minus 1 as x approaches 7. So we can break that up into the limit of x plus 2 as x approaches 7 plus the limit of 1 as x approaches 7 all over the limit of x minus 3 as x approaches 7 minus the limit of 1 as x approaches 7. So this becomes the whole root of the limit of x plus limit of 2 as x approaches 7 plus the limit of 1 as x approaches 7, all divided by the square root of the limit of x minus the limit of 3 as x approaches 7 and as x approaches 7 minus the limit of 1 as x approaches 7. If we're going to plug our numbers in, we get 7 plus 2 plus 1 divided by the root of 7 minus 3 minus 1. So this is root 9 equals 3 plus 1, root 4 equals 2 minus 1. So 4 over 1 equals 4. And so we move to the very last question of this video, the limit of 1 over root 6y plus 1. So this is quotient rule and root rule. Pretty straightforward. We can separate this into the limit of 1 as y approaches 4 over the root of the limit of 6y plus 1 as y approaches 4. That can be further simplified into the limit of 1 as y approaches 4 over root of 6 times the limit of y plus the limit of 1 as y approaches 4 and as y approaches 4. Plugging in numbers, we get 1 over the square root of 6 times 4 plus 1 equals 1 over the square root of 25. This equals 1 over 5.